MiG-29K. MiG-29K. The Mikoyan MiG-29K, Russian, 29K, NATO reporting name, Fulcrum D, is a Russian all-weather carrier-based multi-role fighter aircraft developed by the Mikoyan Design Bureau. The MiG-29K was developed in the late 1980s from the MiG-29M. Mikoyan describes it as a 4+ generation aircraft. Production standard MiG-29Ks differ from prototypes in features such as a multifunction radar and several new cockpit displays, the adoption of HOTAS, hands-on throttle and stick, controls, the integration of RVVAE, also known as R-77, air-to-air missiles, along with missiles for anti-ship and anti-radar operations, and several ground/strike precision-guided weapons. The MiG-29K was not ordered into production and only 2 prototypes were originally built because the Russian Navy preferred the Su-27K, later redesignated Su-33, in the early 1990s. Mikoyan did not stop its work on the MiG-29K aircraft despite the lack of financing since 1992. The program got a boost in the late 1990s to meet an Indian requirement for a shipborne fighter following the purchase of a former Soviet aircraft carrier, and the MiG-29K was first received by the Indian Naval Air Arm in 2009. The Russian Navy, with their Su-33s nearing the end of their service lives by 2010, has also ordered the MiG-29K as a replacement. Development. Origins. The MiG-29K project was initiated in the late 1970s when the Soviet Navy developed a requirement for a supersonic carrier-based fighter. As a first step to meet this requirement, the Mikoyan Design Bureau designed a proof-of-concept version of the MiG-29 fitted with a stronger undercarriage and a reinforced tail section with an arrestor hook, the MiG-29 KVP, Karakiy Vzlety Posadka, or short takeoff and landing.
The KVP first flew on August 21, 1982, and was subject to extensive trials which demonstrated it could safely operate from a ski jump, but ideally a production aircraft needed more power and greater wing area.
It was decided to base the definitive naval version on the advanced MiG-29M, Izdalai Product 9.15, that was already under development, further modified with new undercarriage and folding wings of greater area, with the new model designated the MiG-29K, Korabelny, ship-based, or Project 9-31. The MiG-29K differed considerably from the MiG-29 production model, featuring a new multifunction radar, dubbed Zook, a cockpit with monochrome display and use of the HOTAS, hands-on throttle and stick, principle, the RVVAE air-to-air active homing missiles, anti-ship and anti-radar missiles, as well as air-to-ground precision-guided weapons. To protect the engine from foreign object damage, FOD, the engine inlets were fitted with retractable grills for airflow, rather than metal doors and leading-edge extension auxiliary intake louvers used by land-based MiG-29s.
The MiG-29K's first flight was performed on July 23, 1988 at Sakai by test pilot Taktar Bakarov. On November 1, 1989, on the same day as the Sukhoi Su-27K, N2, Bakarov executed the first carrier landing of MiG-29K on the aircraft-carrying cruiser Tbilisi, now known as Admiral Kuznetsov. The first takeoff from the carrier's deck was successfully performed the same day.
During 1989 to 1991, the MiG-29K underwent further tests aboard Admiral Kuznetsov. The project was put on hold with the collapse of the Soviet Union, while the Russian Navy only pursued the rival Su-33. Mikoyan continued work on the MiG-29K despite the lack of funding. During its tests aboard Admiral Kuznetsov, the aircraft had a springboard-assisted takeoff from strips 195 meters, 640 feet, and 95 meters, 312 feet, long. According to the results of the tests, the landing accuracy proved to be very high, which made it possible at a later stage to switch over to a 3-cable arrestor system on Admiral Gorshkov. The landing accuracy is additionally enhanced through the employment of an autothrottle system. The takeoff characteristics allow for most flights to be possible under tropical conditions at a ship speed of 10 knots, 19 kilometers per hour, 12 miles per hour. Revival. The MiG-29K program was revived in response to the decision of the Indian Navy to acquire the former Soviet Navy aircraft carrier Admiral Gorshkov in 2004. When Admiral Gorshkov was part of the Soviet fleet, it was a hybrid aircraft carrier/cruiser using vertical takeoff (V/STOL) aircraft, thus the deck was refurbished with a takeoff ramp and arrestor wires for operating MiG-29KS. The aircraft has an enlarged and folding wing, an arrestor hook and a corrosion-protected reinforced fuselage. One factor favoring the MiG-29K over the Su-33 in the Indian decision was the larger size of the Su-33, which further limited the number of aircraft on deck. Modifications were made to the MiG-29K for Indian requirements, including the Zuk-ME radar, RD-33MK engine, a combat payload up to 5,500 kilograms, 12,100 pounds, 13 weapon stations, and updated 4-channel digital fly-by-wire flight control system. It is compatible with the full range of weapons carried by the MiG-29M and MiG-29 SMT. The problem of lack of aircraft carrier-based AWACS platform may be tackled by further development of dual-seat MiG-29KUB. It is theoretically possible to outfit the MiG-29KUB with powerful radar and encrypted data links to permit networking of multiple MiG-29KUB aircraft for AEW coverage. The MiG-29KUB may also be enhanced in areas such as electronic warfare and long-range interdiction.
The MiG-29KUB two-seat variant took its first flight on January 20, 2007, followed by the MiG-29K on June 25, 2007.
Design. The MiG-29K is drastically modified from the McCoy MiG-29M for naval operations. The airframe and undercarriage are reinforced to withstand the stress experienced upon landing. Folding wings, an arrestor hook, and catapult attachments were added for carrier operations. The aircraft's undercarriage track was also widened. The MiG-29K, unlike the early MiG-29, can both conduct aerial refueling and buddy refuel other aircraft. The MiG-29K has two widely spaced RD-33MKs. The early prototypes were fitted with two RD-33K turbofan engines, each with afterburner thrust of 86.3 knots, 19,800 pounds, and a possible takeoff thrust of 92.2 knots, 20,723 lbf, for shipborne operations. The RD-33MK engine features 7% higher power over the base RD-33, enabled by the usage of improved materials for the turbine blades. Internal fuel was increased from 3,340 to 4,560 kilograms, 7,360 to 10,100 pounds, to give a combat radius of 850 kilometers, 531 miles. The combat radius can be increased to 1,300 kilometers, 810 miles, with 3 underwing fuel drop tanks. The maximum weight of the aircraft grew from 19.5 to 22.4 t, 43,000 to 49,400 pounds, to allow for increased payloads. The MiG-29KUB two-seat fighter, intended for pilot training, can also conduct combat missions identical to the single-seat fighter. Cockpit and avionics. The aircraft is equipped with 3 multifunctional color liquid crystal displays, 7 LCDs on the MiG-29KUB, a 4-channel digital fly-by-wire flight control system, passive homing system for anti-radar missiles, Sigma 95 GPS receiver, Top Gun helmet-mounted targeting system and electronic countermeasures, ECM. Additionally, an onboard oxygen generating system eliminates the need for heavy oxygen canisters. The types of combat missions undertaken by the MiG-29K can be increased by adding optronics/infrared imaging reconnaissance pods. The Zuk-ME is a development of the N010 Zuk radar, introducing functions such as terrain mapping and following. The radar, weighing 220 kilograms, 490 pounds, features improved signal processing and a detection range of up to 120 kilometers, 75 miles, versus a 5 square meters RCS target for the export variant. In the air targeting mode, up to 10 targets can be tracked and 4 targets engaged simultaneously. In air-to-surface mode, the radar can detect a tank from up to 25 kilometers, 16 miles, away, and a bridge from 120 kilometers, 75 miles, away. A naval destroyer could be detected up to 300 kilometers, 190 miles, away, while up to 2 surface targets can be tracked at once. The radar has a scanning area of plus or minus 85 degrees in azimuth and plus 56/40 in elevation. The Zuk-AE radar was developed with modular approach, enabling upgrade of existing Zuk-ME radars deployed in MiG-29 platforms into the Active Electronically Scanned Array, AESA, Zuk-AE standard. India is already operating the BARS phased array radar on its Su-30 MKI and has specified AESA as a critical element of the MRCA platform. The MiG-29K can be outfitted with an IRST system integrated with both optical and laser systems. It can provide targeting solutions for ground and air targets at up to 15 kilometers, 9.3 miles, with all-round 360-degree coverage. The IRST can also provide detailed trajectories of missiles at closer ranges. Weapons and defensive capabilities. MiG-29K has a GSH 30-130mm cannon in the port wing root. It has provisions for laser-guided and electro-optical bombs, as well as air-to-surface missiles like KH-25ML/25MP, KH-29T, KH-31G/31A, KH-35U, and rockets. KH-31P passive radar seeker missiles are used as anti-radiation missiles. KH-35, KH-31A anti-ship missiles are for anti-ship roles, for aerial combat air-to-air missile like RVVAE, R-27ER/ET, and R-73E are fitted. The aircraft is also adaptable to various foreign weapons. The MiG-29K has a combination of low observable technology, advanced electronic warfare capabilities, reduced ballistic vulnerability, and standoff weapons to enhance the fighter's survivability. According to McCoyan, extensive use of radar-absorbent materials reduced the MiG-29K's radar signature 4 to 5 times over the basic MiG-29. The RD-33MK turbofan engine was also engineered to reduce infrared signature and improve aircraft camouflage. Operational history. In 2004, India ordered 12 MiG-29K single-seat and 4 MiG-29K UB two-seat fighters. The MiG-29K is to provide both airborne fleet air defense and surface attack capabilities. Deliveries began in December 2009. Prior to their delivery to India, the MiG-29KS underwent testing on board Admiral Kuznetsov. In January 2010, India and Russia signed a deal worth $1.2 billion for the Indian Navy to receive an additional 29 MiG-29KS. The MiG-29K entered operational service with India in February 2010. Further deliveries of 5 MiG-29KS and a flight simulator took place in May 2011. Further deliveries are to continue through 2012. The fighters were based at INS Hansa in Goa on India's west coast until Admiral Gorshkov joined the Navy under the name of INS Vikramaditya in last quarter of 2013. Vikramaditya was expected to carry up to 24 MiG-29K/KUB fighters. The future indigenous aircraft carrier INS Vikrant, being built by India, is also likely to carry these aircraft. Further MiG-29K orders by India were frozen after a MiG-29K UB crashed during testing in Russia prior to delivery to India. The Indian Defense Ministry commented that the crash cast a shadow on the credibility of the aircraft. Russia later announced that pilot error had caused the crash, and there was no need to ground the aircraft. In August 2011, MiG's General Director Sergei Korotkov announced that the final 5 out of the 16 aircraft contracted in 2004 would be delivered by the end of the year, and that deliveries of a second batch of 29 MiG-29KS would begin in 2012. In November 2012, the MiG-29K/KUB completed sea trials for the Indian Navy. One problem is that Western and Ukrainian sanctions on Russia have prevented McCoyan importing components for assembly at the factory. Instead, they have had to be installed on the flight line in India. In a 2016 report, India's National Auditor CAG criticized the aircraft due to defects in engines, airframes, and fly-by-wire systems. The serviceability of MiG-29K was reported ranging from 15.93% to 37.63%, and that of MiG-29KUB ranging from 21.3% to 47.14%, with 40 engines, 62%, being rejected/withdrawn from service due to design defects. These defects are likely to reduce the service life of the aircraft from the stated 6,000 hours. However, it was reported that recent efforts made by the two countries have improved serviceability to around 70%. In 2017, the Indian government announced a planned replacement of the MiG-29 with 57 new aircraft, with a competition primarily between the French Dassault Rafale and the American Boeing F/A-18E/F Super Hornet. In December 2018, when addressing the press on the eve of Navy Day, CNS Admiral Lanba noted regarding the MiG-29K, there is no issue on supplies of spare parts from Russia at the moment. The MiG-29K fleet has been performing well now. The Indian Navy plans to deploy the MiG-29K on board its first domestically built carrier, the INS Vikrant, and will acquire further combat jets with updated capabilities for this purpose. Indian Navy Chief Admiral Sunil Lanba announced that issues related to maintenance and availability of spare parts for the MiG-29K fleet, which had previously undermined their readiness, had been resolved. Russia. The 279th Shipborne Fighter Aviation Regiment of the Russian Navy has a fleet of 21 Su-33 fighters whose service lives were expected to be reached by 2015. Around 10 to 12 will receive an upgrade, including the Jeffest SVP-24 bombsight for freefall bombs, giving them a limited ground attack capability, but more aircraft were needed. It was less cost-effective to open the Su-33 production line for a small run than to piggyback on the Indian Navy's order of MiG-29Ks. India paid $730 million for the development and delivery of 16 units, while 24 for the Russian Navy would cost approximately $1 billion. The Russian Navy ordered 24 MiG-29Ks in late 2009 for Admiral Kuznetsov. Deliveries of the MiG-29K for the Russian Navy started in 2010. MiG and Russia were in final negotiations for an order for more MiG-29K/KUB aircraft in August 2011. An order for 20 MiG-29KR fighter bombers and 4 MiG-29KUBR operational trainers for operation from Admiral Kuznetsov, replacing the Sukhoi Su-33, was officially announced in February 2012. However, in 2015, Major General Igor Kozin, the commander of the Navy's Air and Air Defense Forces, announced that a second fighter regiment would be formed to augment the current force, with the intention that the MiG-29s be used by this new unit, with some existing Su-33s refurbished for further use. In October 2016, for MiG-29KR/KUBR from the 100th Independent Shipborne Fighter Aviation Regiment formed part of the air group aboard Admiral Kuznetsov as the ship deployed with its battle group to the Mediterranean Sea as part of the Russian campaign in Syria.
On November 13, 2016, a MiG-29KUBR on operations in the Mediterranean crashed en route back to Admiral Kuznetsov.